As we continue our module on labor demand elasticity, we'll now take a look at the simple formula for calculating the elasticity of labor demand. We'll differentiate that from the midpoint formula, which we'll focus on in another segment later in this module. So let's take a look at the basic formation of this equation. We noted in the previous segment that the basic equation is elasticity is equal to some percentage change in quantity, or labor quantity in this case, divided by some percentage change in price or wage in this case. Well, this is simply two structures of the percent change formula being divided by each other. So let's look at what that percent change formula looks like. If we're thinking about the percentage change in prices, the percentage change formula is noted as P2 minus P1 divided by P1 times 100, where P1 is the original price, P2 is the price that is being changed to. So when we have P2 minus P1, we have the change in price divided by the original price, such that we now have this as a decimal, and this gives us a percentage change from the original basis that we have. So let's go ahead and use that structure in both the denominator and the numerator of the simple formula. Such that we have L2 minus L1 divided by L1, and that divided by W2 minus W1 divided by W1. That's going to give us some value, and that value is going to be our elasticity, of course. We would expect that value to be negative when we're dealing with demand, because we know that the demand curve is downward sloped. So we would think we're going to have something negative. Let's look at an example for this. Let's assume that we have a worker with a wage of, let's say, 10, and that type of worker with that wage, there are 25 of those workers that are required or demanded in the marketplace. But that the wage for that type of worker now increases to 11, and so we know then that the demand for that type of worker is going to now decrease as wage rises. The number of labor units decreases. That's reflected in the decreasing slope, the negative slope of the labor demand curve. So let's say that actually is now 18. Well, putting the simple formula to work here, let's do this over here. We're going to then have 25, or L2, 25 minus 18 divided by 18. And that will be divided by 11 minus 10 divided by 10. So we can then rewrite that. I believe I've done these values in the numerator here backwards. This should have been L2 minus L1, so it should have been 18 minus 25 divided by 25. So now we're going to think about this. This will be negative 7 divided by 25. And now all of that divided by 1 divided by 10. Well, I don't know about you, but I don't enjoy complex fractions, dividing fractions within fractions. So I would prefer to look at this a little bit differently. I prefer to say that this is the same as negative 7 divided by 25 times 10 divided by 1. And now we can just multiply those across such that it is negative 70 divided by 25. Which is greater than the absolute value of negative 1. The reason we talk about being greater than the absolute value of negative 1 rather than just greater than 1 is because we expect a negative value if this is a demand elasticity, but we might expect a positive value if it's a supply elasticity. And as we think about how we evaluate these in a moment to determine whether elastic or they're inelastic or unitary elastic, we don't want to have to keep thinking back and forth about whether it's negative or positive. So we just compare it to the absolute value of negative 1, which will strip any negative operator away from it. So now let's think about what this might mean to us. I'm going to suggest that since this is greater than the absolute value of negative 1, that this would be elastic. which would tell us that as the price has changed, then we have some greater change in the quantity. So as the wage rose from 10 to 11, or a 10% rise in wage, we have an even greater change in the percent decrease in the labor units. Well, let's think about how that works out for us. If we have elastic such that we have our elasticity value greater than the absolute value of -1, then we're simply saying that as wage changes, the number of labor units change even more proportionately. If it's inelastic, then what we're saying is as the wage changes, the number of labor units changes even less proportionally. And unitary elastic is telling us that as the wage changes, the number of labor units changes exactly with the same proportion. Well, we looked here at the simple formula in calculation. Let's think back to this formula now in respect to the percentage change structure that I've given up here. Remember that we have 7 divided by 25. So 7 divided by 25 is actually 0.28, or 28%. 1 divided by 10 is 0.10, of course, or 10%. So let's look at it over in this structure. We know that if that is what we had, 28% divided by 10%, and that was a negative 28%, well, that's greater than the absolute value of -1. Let's assume for a moment that it was different, that we actually had only seen a 7% change. Let's say that we had something that was 7% decline in the face of a 10% rise in wage. That would be less than the absolute value of -1. That would be inelastic. Or similarly, if we saw, let's say, 10% and 10%, again, we expect it to be negative since it's demand, that's going to be equal to the absolute value of -1. So we evaluate the elasticity values. We classify them as elastic, inelastic, and unitary elastic based upon their value and the comparison of that value to the absolute value of -1.